My name is Espen. I work for a company called Type A Machines. We build 3D printers. How many of you guys have a 3D printer? Hand in the air. How many of you wish you had a 3D printer? Yay, potential market. So it's interesting, 3D printing, if I asked that question about a year ago, I'd actually ask, I'd see maybe one hand in the audience if I was lucky, and usually it would be Andrew, our founder, sitting at front and grinning at me. Thanks, man. So what's happened just in the space of 1 year is that, first of all, people have heard about 3D printing, and second of all, more and more people are getting 3D printers as well. I want to talk a little bit about what's next, and I'm going to take a little gamble and paint some big predictions, and then you guys can call me out on it in 6 months. How does that sound? Yeah? All right, awesome. Okay, so we'll do that. So, so this is kind of like just a deep dive into the realm of possibility, if you want, from the perspective of someone who's really in the charge at the moment, right? So my job as CEO at Type A Machines is really to try to figure out, okay, what's the next 6 months? And by the way, 6 months in this industry is a long time. So what does the next 6 months kind of entail? And what's important and what's less important to focus on as well. Just a little bit about our company before I begin, just so you know how tiny we are. We started out in January 2012. This time last year we were 4 people, we're 18 people now. So that's kind of like the rate of acceleration. We're still producing south of 20 units a week. To put that in context, last time we heard from MakerBot, they were producing about 700 units a week. MakerBot being the biggest industry desktop 3D printing manufacturer at the moment. And so, it's a big blue ocean out there. Everyone's producing as many printers as they can. The lead times are insane. And it's going down now as we're professionalizing our manufacturing, but there are about 108 different 3D printing manufacturers out there at this point in time. Many of them are, single or 2-3 people startups, and a lot of Kickstarter campaigns as well, which we really love. I wanted to pick up on something you said, Ted, which was the lifestyle decision of 3D printing. And I like to tell my wife the key to happiness is lower expectations, and it's a little bit like that with 3D printing as well. She still doesn't buy it. Okay, so one of the things that's really important to know when I'm talking about 3D printing is that 3D printing is not a magic box, okay? It's not something that's just going to make everything wonderfully the first time. But it is starting to get to a point where they're reliable enough for office use and ultimately desktop use as well. And I'll walk you through some of the different things. I think I'm going to start off just by taking a little look back before I start looking forward. So just to give you an idea of some of the cool stuff you can 3D print, this is actually partially 3D printed and partially laser cut structure that we had for Burning Man. Some of my stuff, Milo, Alexander, amongst others, essentially 3D printed a whole bunch of stuff, brought it over to Burning Man, and they did this all in the space of really just a weekend. And very quickly set up a little sort of cathedral-style temple there. So there's already a whole bunch of stuff, and I'm quite sure some of you have seen 3D printed architecture, 3D printed objects. We saw some there. There's a whole bunch over at the table at the back there as well. I might even run over and bring some forward in a bit. Ooh, hang on. This is my magic trick. Let's see. I brought some parts as well. So I brought a 3D printed Frisbee, just to give you an idea of what, and I'm actually going to throw it. It's quite hard, so be careful. But here it goes, if I break something. So you guys have to be ready. I'm going to throw this thing. Are you guys ready to catch? Just to wake everyone up. Are you ready? All right, here we go. Nice catch. All right. Pass it around and have it end up on the table over there. All right. I hope there's no legal team here going, ooh, okay. 6 months ago, we were producing this machine, and we're just sunsetting it right now. You'll notice that it's plywood. Plywood's a really, really great material to work with, partly because it lets you iterate very quickly. These printers are laser cut on a laser. So part of the reason when we started off with the RepRap 3D printer derivative, we looked at whether we should 3D print a 3D printer. But 3D printing a 3D printer is actually a really, really bad idea if you're trying to mass produce them, because 3D printing isn't a tool for mass production just yet. Okay? So a laser cutter, on the other hand, is a little bit more reliable. And the best part of using a laser cutter is that you can actually upgrade the files on the go. So, you know, our first printer looked pretty much the same thing, but we've moved around bolt holes, we've upgraded components, we've changed it a lot in the space of just 1 year. And the reason we've been able to do that so quickly and iteratively is because the laser cutter has 0 upfront tooling costs. It really costs us nothing to just change the design files. And so one of the things that makes that really important is because the pace of innovation in 3D printing right now is insane. Right? Every week there's a new technology coming out. And we've had to think very carefully about this in terms of accessible source as well. Open versus closed is a big debate. Ted mentioned it a little bit. You were saddened to see MakerBot go away from their open source and into closed source. We've had to think very carefully about this as well. And what we've actually come up with is what we call accessible source. So we will take patents because it's important, both for our investors and in order to protect ourselves from essentially Chinese knockoffs. But what the open source community really believes in is access and being able to share designs and you know, within the community develop the product. And so we've had to, when we're building our company, just these last 6 months, think very carefully about, okay, what's our stance on this? And the reason that's so important is because if you go closed source, you're locking out a lot of really valuable R&D, and you're also kind of like taking a step away from the community in terms of the pace of innovation. So you really don't want to do that. So we believe we found sort of like a golden middle path by embracing what we call accessible source. And it basically means we take patents, but we build a printer that is very modifiable, hackable, and open for people to change. And that's actually really, really hard because we've had to do things like what we did just last week, which was rewrite the warranties. Now, all warranties out there at the moment are written, that we've at least been able to find, are written in such a way that the moment you open up your printer, you void the warranty, right? That's no good when it comes to accessible source because we want people to hack our printer. We've got a 12-year-old, well, actually he's 13 now, we've got a 13-year-old down in Palo Alto who's been hacking our printer for the last couple of months, and he just built a Frostruder, icing 3D printer extruder that prints in icing sugar, right? He couldn't do that if he was worried about voiding his warranty. So we've rewritten the warranty to basically say, you're free to take apart the machine, play around with it. If you want tech support, we may have to resort to restoring you to factory settings, but that's it. Right. So this was 6 months ago and up to date. This is tomorrow, like literally tomorrow. That's our new machine right there. And that's going up on our website. This is, hopefully you'll agree, a step in the right direction. There's still a long way to go. But this is a Wi-Fi enabled 3D printer that prints basically a foot in cube, so 12 inches by 12 inches by 12 inches. And the most important thing for me about that whole printer is that it's modular, meaning you can take apart parts of it, like the print head, and replace it with a different type of technology as that technology becomes available. All right? So we've really had to think, looking forward, what's next? And I'll give you a little spoiler alert in terms of the rest of my talk. The short answer is, we have no idea. Okay? I'll expand on that, but the short answer is we have no idea. And that's why modular technology is so beautiful and important, because it lets you keep on iterating. And if you buy a 3D printer that's modular, it means that you don't have to buy a whole new one in 6 months' time. You can actually just upgrade the one you have. All right? So that just gives you some insight into our thinking. There are a couple of bottlenecks in the industry right now that I think are important to kind of like highlight. The first one is 3D modeling software is very limited right now. There's some really, really great programs out there, but the biggest challenge as I see it is the mouse is a really poor interface for 3D modeling. It's not particularly intuitive. We work a lot with kids, And they have, like, they get it faster than I do, by the way, but it's still not very intuitive to work with. So getting some sort of like gesture recognition or something along those lines might be much better. The other big challenge right now is click-to-print integration across the different services. Right now, for a lot of these printers, if you want to print a file, you have to use 2 or even 3 different programs in order to do so. That's way too much. You should just be able to click and have it print. The printer is really just a tool that should be in the background, right? The other big bottleneck is 3D printing as a tool for single unit production rather than mass production. And I think particularly it's just about speed. The speed's too slow. So, if you think about what we're working on trying to develop right now, across the industry, there are 4 things that really, really matter. Speed, accuracy, reliability, and ease of use. Those are the 4 things. Like I can promise you, every single 3D printer manufacturer in the world right now, that's what they're working on. Probably working on other stuff as well, but that's like really the core. And that's what we're trying to push. So if you think 6 months ahead, the speed, the accuracy, the reliability, and the ease of use is going to improve. Like, no questions asked. Question is, how much will it improve? So I think that there's some really interesting things going on now. We are now at the point where the mean time between failures for an expert user is about 1,000 hours. It's 8,000 if you don't count hot end failures, which is the biggest like pinch point in the industry. 8,000 hours isn't a bad thing, all right? Like, it could be a lot better, but that's starting to become respectable. What's not so cool is that if you're a novice user right now, that's not the mean time between failures. Most novice users, their first print is crap. My first print was crap. I couldn't get it to work first time. And that's the big truth, is like right now there's a whole bunch of education and design that needs to go into making it easier for users to use as well. And there are some physical limitations that I'll come back to as well. But let's start looking ahead a little bit. This is something that one of our employees, Brian Allen, printed as part of a project he did for his own design studio. And this is what he calls varun. This is approximately 10,000 hours of 3D printing right there. Yeah. He had basically like 7 machines running for months and months and months over the summer, and basically managed to put this all together as a single sort of beautiful object out in the forest. But it's absolutely useless. You can't use it for anything. But it's beautiful, right? But let me tell you a little bit about why I think it's important and why I put this slide up here. A lot of things, when you first look at them, are absolutely useless, right? But the thinking behind it is actually really interesting, because this was printed on a desktop 3D printer, right? And so you can build really large parts on a desktop 3D printer. In fact, if I skip back a slide, here's a really good example. That fan blade that you're seeing just next to the printer, that's the fan blade of a Trent 900 Rolls-Royce Airbus jet engine. Okay, that's 1/6 scale, by the way, and I wouldn't recommend flying in it. But we wanted to build one because we thought it would be fun. So we out of curiosity, we sent one off to Shapeways to see how much it would cost to build and how much time it would take to build it. Can anyone guess how much it would cost? $10,000. $10,000, a little bit high. $5,000. $4,100. And it would take 3 weeks, right? In context, that printer is $2,300. And it took less than a week to print. It took us 90 hours and 33 clicks of the print button, right? So the speed of implementation is actually really, really powerful here. And the cost is going down. So particularly for prototyping purposes, I think 3D printing is really powerful. And I think that's what enterprise architects, engineers, designers are starting to wake up to, that they're seeing, hang on, I can do this on my desktop and not have to wait those 3 weeks to get that part. But I don't think you're going to see it necessarily in the home just yet, unless you're a hobbyist, unless you really enjoy building robots or model trains or something else. Because the technology simply isn't ready yet. Ask me again in like 8 months. Like that's kind of like the speed that things are happening in. But I do think that there are a couple of things that are worth thinking about as well that we're starting to see. So, my job is working with vendors, working with our resellers, working with our customers to try to see what the landscape will be like in the next couple of months. And what we're starting to see right now is a clustering. So within the desktop 3D printing market, there's a clustering in terms of the race to the bottom, trying to make the cheapest possible 3D printer. There's a Peachy printer out on Kickstarter now for $100. It's probably not going to print very well, but it's $100. It doesn't have to. It's a great way to learn about 3D printing. Okay, and then you have like what they call the prosumer market. I hate that word, but that's what people are using. It's basically sort of higher end consumer market, lower end enterprise market, right? We're starting to see a whole bunch of different clusters around that as well. And what's happened there, so we're kind of paced along there as well. The reason we priced it at the price that we did was we just looked at the MacBook Pro and said, okay, well, Apple spent millions and millions of dollars on pricing. We don't have millions and millions of dollars to spend. Let's go with that, and then we'll adjust as we get more data. It works. And then you have the higher end enterprise market, right? So what's happening there is like some of the printers that Ted showed, the $50,000, the $100,000 printer. No one's going to have them at home. You may have a desktop 3D printer if you're into that and you can see immediate uses. And then down the line, and by the way, I'm talking primarily about like the desktop 3D printing technologies here. I'm not really going to get into like metal sintering and all of that stuff because it gets more complicated really, really quickly. But for the desktop space, we calculated that with our printer, once we reach a 10,000 unit volume, we can drop our prices to below $500 if need be. All right? So that suddenly becomes more realistic, right? Yeah. Except that the ease of use is horrible. So you don't want to do that just yet, right? It's reliable enough now to work for someone who's taken a little course and gotten a little bit of insight, but it's not reliable enough for my mom to be able to use it just yet. Don't tell her I said that. What we're seeing is there's the desktop market, but there's also a couple of other markets opening up as well. And interestingly, we're starting to see like 3 different places. So you've got the factory in the cloud, like Shapeways or Pinocchio over in Oakland, where you can go and order stuff. Then you have your desktop 3D printer. There's also a third space, and that's like your Kinko's corner store. And there's actually a store that just opened up over in Oakland called Honeybee 3D. I'd encourage people to check that out. And Tech Shop, of course, just down the road from here. These spaces are starting to provide 3D printing services and 3D printing classes and a whole bunch of different things, an extension of what they already do. And I think that's a really interesting local thing as well, because as 3D printing expands, it's essentially going to become an extension of the internet, right? So what does that mean? Well, no one really knows, but think about all the things on the internet. And then, try not to think about it just before you go to sleep, by the way. Yeah. But it's a really, really interesting space. People ask me about 3D printed guns all the time. How many of you have heard about 3D printed guns? Hands in the air. Right. So 3D printed guns, some people have 3D printed guns, right? It's possible, you can do it. And I wouldn't recommend it because you're more likely to injure yourself than someone else. But that doesn't stop people from trying. We actually have to take this seriously because although there are many, many ways to create weapons that are way more reliable and better than a 3D printed gun, we work a lot with schools. And of course, the first thing that a kid will want to do is 3D print a gun, right? No? Oh yeah? What's the first thing you'd 3D print?
Probably an iPhone.
There you go. All right, I retract that. Awesome. So But it is something that we have to take seriously. And there are ways of doing that as well. It's no more dangerous than using a lathe or any other piece of shop equipment. And in fact, lathes are probably way more dangerous. Yeah. Okay, so 3D printing as the extension of the internet is an interesting thing, but I think that there are some technologies that are going to lend themselves to doing that as well. The first one I want to talk about is just, I'm just going to name them because there's a lot of technologies, but I think gesture recognition is really, really interesting within 3D modeling because it's much more intuitive. And we were actually talking about this earlier. I don't think necessarily we agree, but I do think that being able to use your hands when modeling is much more powerful. And we did a project with the California Academy of Sciences a little while back where we actually had the kids modeling clay and then we 3D scan them. And it just works better. Then you can go in and you can interact with the model afterwards. The other technology that I just mentioned is 3D scanning. 3D scanning is becoming increasingly powerful now. There's an app that you can get on your iPhone called 12-3D Catch, made by Autodesk, and I'd really recommend it if you want to start playing around with 3D modeling, because it essentially lets you just take your phone and then just take 30 to 40 pictures around an object, and then send those pictures to the cloud, and it'll give you back a 3D model. I've been using this for practical joke purposes because. Well, I probably shouldn't say this on camera. Well, so my Christmas present to pretty much all my family this year is going to be me as a garden gnome. And I've also gotten a couple of my friends. I've done 1-3D catch pictures of them. And I'm going to turn their face into a doorbell. So if you press their nose, it goes ding dong. I mean, you can do all kinds of different silly things. Let me get back though to some of the technology things that I'm seeing. So gesture recognition, 3D scanning, and I think the next step there is 3D video scanning. No one wants to have to sit and take 30 pictures around a person, right? You just want to turn on your video camera and go shwoop. And I'm pretty sure that's just going to be a matter of time. The other element as well is secondary processes. I wrote another thing. Don't worry, I'm not going to throw this, by the way. Because it's like a solid block of aluminium. So right now, 3D printing is limited to really sub-100 unit production, right? And in fact, you really don't want to print 100 units of something on 3D printing because it's going to take you forever. But what if you could 3D print molds for injection molding? Right? The most expensive part of injection molding right now is the tooling. Because you have to essentially, machine out the templates. But if you could just 3D print the templates, then those costs would go down and you'd be able to mass produce stuff much faster, right? Another thing, and sadly I didn't bring an example of this, but we do have one in-house somewhere. I just couldn't find it under the mess that is my R&D department's desk, is metal sand casting. So 3D printing molds for sand casting so that you can take a plastic component and turn it into metal. I think those are two things that really the market hasn't picked up on within 3D printing just yet, but that can be really, really powerful. So those are a couple of things that I think are sort of like emerging technologies within this. I think there are some overall larger trends as well. So one of them is, mass customization isn't just about 3D printing. It's actually about, Saul Griffiths from other labs said this really well. He talked about desktop precision. Being able to, create a pick-and-place machine or a desktop CNC mill or a desktop 3D printer. They're all about precision, being able to do precision faster and cheaper than ever before. And I think that's a trend that's going to continue. The other element as well is looking at local manufacturing as opposed to manufacturing something overseas. And local increasingly is global, particularly if you have a 3D printing hotspot in every city in the world. And that's what we're starting to see develop now. I'm being contacted multiple times a week by various different vendors that are looking to set up some sort of 3D printing hotspot where they provide 3D printing services, they sell 3D printers, and they provide courses. So local is global. But I would say that there is a challenge in terms of learning from the music industry, right? Because a lot of this has to do with actually having functional objects. So from a mass consumer market point of view, until you actually have access to functional objects online, and there are some out there, like a friend of us, Joshua Pierce from Michigan Tech University, he published a list a couple of weeks back of 20 things that you can 3D print cheaper than you can buy them at Walmart, right? But those are the exceptions. If you go to our blog, you can see it there, typeamachines.com, little plug. But you know, those things are more the exception than the rule. What's really missing right now is more content. When is IKEA going to publish their models for 3D printing those annoying little plastic parts that are always missing in the box, right? Like, that's the next step. So I think that's a big thing. And then I want to talk a little bit about how hardware and software is merging as well. And we see this because we're in hardware. And by the way, hardware is not the new software. There's a word in the word hardware. Hardware is hard. There's a reason it's called hardware. Having spent a year and a half now trying to build like 3D printers and get them out the door and getting the manufacturing pipeline up, it's hard because you have to think about, you know, sourcing your supply lines, secondary suppliers, all of that stuff. So hardware is not the new software, but hardware and software is increasingly becoming integrated. And I think it's part of the larger trend that's like the smart home, you know. You don't want your laptop to be carried around with you all the time anymore. You just want your phone in your pocket maybe, and then everything else around you should just be smart, right? Your fridge should talk to your phone so that you have a shopping list when you go into the store in order to be able to, you know, buy your groceries and so on. And 3D printing is part of that as well because it enables you to put, you know, embedded electronics and develop things much faster. But also, you know, it merges hardware and software in a way that is much more about user experience than anything else. So that's kind of like one of the trends that I predict. And maybe I'm wrong. But I want to kind of finish up because that's important to finish at some point, right? And I want to talk a little bit about the thing that's most important for me right now. And apart from growing a company, that's pretty important. The thing that I'm spending a lot of time thinking about right now is how 3D printing is going to start spreading. And right now, I've been talking to unified school districts across the US, and they have very different levels of money based on performance primarily. But the ratio, like in some unified school districts, they get 1/15 of the resources. And this is, I'm not going to mention any names, but this is like literally here in the Bay Area. Some unified school districts get like 1/15 the resources of other unified school districts. That's a massive disparity, right? What does that mean for students learning to 3D print? Put yourself back into your shoes as a 12-year-old or a 13-year-old. What would you do if you had access to a 3D printer? Right? Like, this is so important to me because I believe that we actually have a responsibility in terms of education. And our responsibility is to ultimately ensure that there's a 3D printer at the hand of every child in the world, because it's about empowering them to make the changes. Right? I can't tell them how to run the world, how to change the world, but I can give them the tools to do so. And I think that's something that people in software have been a lot better at doing than people in hardware for a long time. And so I'm going to leave you with this thought. What are we going to do to ensure that every student has access to a 3D printer? Thank you very much.